If 0.440 liters of 0.410 molar H2SO4 is mixed with 0.420 liters of 0.300 molar KOH, what concentration of sulfuric acid remains after neutralization? Okay, so if you can recall the formula for molarity, so we know that molarity is equal to moles per liter. If we multiply both sides of the equation by liter, so liter cancels on the right side. On the right side, you're left with moles. And on the left side, you're left with liters times molarity. So this is our formula. If you want to get the moles, moles is just liters times molarity. Now that we have this formula, let's try to solve how many moles of H2SO4 is given in the problem. So we will use again the formula liters times molarity. So in the problem, we are given 0.440 liters and 0.410 molar of H2SO4. So we just multiply that, 0.440 liters, and then you multiply that with 0.410. We know that molar or capital M is the same as just moles per liters. Okay, so the liters would cancel out. Now you just need to grab your calculator. 0.440 times 0.410, that is equal to 0.1804, and the unit is moles. So this is our moles of H2SO4. Now let's also get the moles of KOH. So let's use the same formula, liters times molarity. So in the problem, we are given 0.420 liters and 0.300 molar. So if we again multiply those two numbers, 0.420 liters times 0.300 moles per liter. So our moles of KOH, so grab your calculator, 0.420 times 0.300, you will get 0.126 moles because the liters cancel out. So 0.126 moles of KOH. Now the problem says that you mixed the H2SO4 and KOH. So H2SO4 is an acid and KOH is a base, right? So what happens when you mix the two? There will be a reaction, an acid-base reaction. So that's also known as neutralization. So that's your acid-base reaction. Okay, now, of course, if there's a reaction, we need to write the balanced chemical reaction between H2SO4 and KOH. So that's H2SO4, 1 mole of H2SO4 plus 2 moles of KOH. The products are potassium sulfate, K2SO4, plus 2 moles of water. So this is the balanced chemical reaction between H2SO4 and KOH. Now again, in the problem, we have solved a while ago that there are 0.126 moles of KOH. And according to the balance reaction, for every 2 moles of KOH, so again, for every 2 moles of KOH, it can neutralize only 1 mole of H2SO4. So that is their molar ratio. For every 2 moles of KOH, it can neutralize 1 mole of H2SO4. So the moles of KOH would cancel out. So that's 0.126 times 1 divided by 2. And that is equal to 0.063 moles of H2SO4. So this is how much H2SO4 that can be neutralized by the KOH. Therefore, you can compute for the remaining moles of H2SO4. So how do you compute for the remaining H2SO4? So remember, initially, we have 0.1804 moles of H2SO4. Now, after the reaction, 0.063 moles was neutralized. Therefore, the remaining H2SO4 is 0.1804 minus 0.063. And that is equal to 0.1174 moles. So this is your remaining moles of H2SO4. Now that we have the remaining moles of H2SO4, we can now calculate for the concentration of H2SO4 because the problem says what concentration of sulfuric acid remains after neutralization. So again, how do you solve for concentration? We already discussed this a while ago. Concentration or molarity is just moles per liter. So moles would be the remaining moles of H2SO4. That's 0.1174 moles. Divided by what would now be the liters. Remember, you mixed two solutions, 0.440 liters and 0.420 liters. You combine them. Therefore, your liters, your denominator would be the total volume. So that's 0.440 liters plus 0.420 liters. And if you solve that using your calculator, you will get approximately 0.137 moles per liter or 0.137 molar. And this is the answer to the question.